So the hard part, and at least a couple of you asked about this, is can more than one model be true? And I think that's the whole point of contextualism or relativity. Relativity doesn't mean nothing is true, which some people use to criticize the concept of relativity. The whole point is that within particular contexts, there are truths. Those are true in that context. So when we look at the geocentric theory, the Earth-centered theory, from the perspective of someone standing on the Earth, looking up, that's the most obvious perspective you could have, and is obviously true from that perspective. Galileo, of course, his significant discovery was that Venus can't be going around the Earth; it has to be going around the sun. And you could look up his drawings, for example. So that, the different, these are actual copies of Galileo's drawings as he saw Venus from his telescope. And what, of course, he's seeing is that there are the same kind of thing that happens with the moon when we see the moon at different stages in its orbit, right? So that because of the way the light from the sun shines on the moon, you end up with different stages or these kinds of things, right? And Venus does the same thing, which means that Venus is going around the sun, not around the Earth. So that was a significant discovery. He assumed that also meant that the Earth went around the sun, and that's actually true, right? From a heliocentric point of view, where you're looking at the solar system, usually from at least a little bit away from it, and you see all the the planets. This is how they go, etc. Not a circle, but an ellipse, usually, right? That was what Kepler figured that out, right? But when we're looking at it that way, yeah, that's a true model or a working model as well. You have to be careful how you say this stuff. What would it be a true model? It's a coherent model, but you have to fix the model, and that's why the Tychonic model is. I had that on here somewhere, don't I? The Tychonic system. You could just look that up and notice that that's Tycho Brahe, his solution, because he didn't want to get in trouble the way Galileo did. And yet at the same time, you had to fix this, obviously, mathematically. So he figured out how to have the Earth at the center, the moon goes around the Earth, the sun goes around the Earth, and all the other planets and objects go around the sun. And so you get the Tychonic model. So that, if you're going to be Earth-centered, that's at least one of the models you have to use. You can't use the Ptolemaic system because that's an error, right? You can't have that. The problem, of course, with this is if you're in this context and you're looking at the stars, when we look at the larger picture, so it's not just the solar system doing this, but you're looking at the solar system as it's cruising along, moving towards Orion, apparently, or in its 250 million year, almost screwed that one up totally, right? 250 million. Sorry I started early. I can't help myself. Entrez, s'il vous plaît. Just push, I guess. There's a way to do it. I don't know how people do it, but so the interesting thing with, when you step back further and you look at that, you realize that, gosh, everything is kind of cruising along, not really even like this. It's kind of almost like a frequency pattern. The one video that shows them all, with terrible music. Sorry about that. I don't know who added that terrible music to it. That's way too fast, and it makes it look like everything is, just constantly spinning like crazy. But obviously, over the course of a year, Jupiter and Saturn don't even get around the whole thing once, right? Neptune doesn't. I mean, Mars might go around, 2.5 times in an Earth year? I don't remember, and Mercury. So that image of everything kind of moving all along would be still another model. And by the way, each of these models, like the Tychonic model, the heliocentric model, the model of everything moving along, whatever that's called, all of those are actually true and not in conflict with one another, because you have to keep in mind that you're looking at a different perspective. If you're trying to send something to Mars, as we have, be careful, because the one time they had both British and Americans working on the project and they missed. You know why?
They were using different measurement systems.
The Brits were using metric, and yes, like how many millions of dollars, and it's just, oops, we missed. Why did we miss? I had exactly the right kilometers. No, miles. No, kilometers. Yeah. Silly stuff.
It was like a conversion error. Like they knew that they were using different, but they thought they could get along with it just by converting.
Just silly stuff. But yeah, if you're trying to do something, you have to use the model that's appropriate to what you're trying to do. And the Earth-centered model, it's neat. And I mentioned, for those that I've sent my response back to, Travis Rector here, who I know has 2 PhDs, one in math and one in astronomy. And he actually publishes books on, all these astronomical images and everything. Fantastic. And he agreed that if you're looking for a planet on another star, the best system to use is the geocentric system, because that simplifies all of the mathematics involved. Because if you're trying to figure out, the Earth is moving and that's moving, yes, Paul?
Is it because all the telescopes are here that we're using to look at that?
I suppose even the ones in space are here.
Yeah.
Yeah.
Like an L1 that's close to us.
Yeah, so that's the perspective you're looking at from, but it simplifies the whole process of figuring out the motions, from what I understand. And the thing is, at the same time that I credit him with giving me that use for that model, Travis is the first one to say, no, but that's not. He would support the heliocentric model as the dominant model, which is what most people, when I ask the question, most of you would offer the heliocentric model as, oh, well, that's what I was taught in high school. Yeah. But what I love to point out too is, and I referenced the book on Galileo by Heilbronn. There he has researched the actual discourse between Pope Urban and Galileo over whether or not he should publish his model. And the Pope clearly in that writing understands that these are two different models. They're both true. But why get everyone upset by publishing this one? But Galileo was like unconvincible. He thought only one model could be true, which in my mind today makes him the dumber person. You know, typically when we look at this conflict, we think, oh, Galileo had, you know, the telescope, you know, other cardinals, bishops, you know, come up and they look at it, I can't see it. And by the way, we now know why none of them could see it. Galileo's eyes were screwed up, and he made the telescope for his eyes. So other people trying to look through his telescope didn't get much out of it. Pretty interesting too. And by the way, I know why Galileo went blind. Don't stare at the sun, and especially don't stare at the sun with a telescope. And he had to keep switching eyes because, you know, the one eye would no longer. It was burning his retinas out, you know, so, you know, be careful, you know. Sorry. So what point am I getting to, actually? And I apply this not just to these astronomical models that you might use, but all of the things that we know are conceptual schemas based on a particular model within which that particular set of data is useful. So this idea of the model being significant for us for any amount of true information that we use is basically applicable to everything we do, right? And we do have conflicts between models. So this is a whole contemporary issue for us already. And you know, we even talk about fake news, right? You know, there's one point of view might point out, oh, that's fake news. Well, from their model, that might actually work. You know, from another model, no, that's wrong. And what we've got are this conflict of models over what's best. You know, what will actually work out, whatever the situation is that you're trying to deal with, right? Morality, for example, one of the things we'll see is that there are lots of different models of morality and so on, right? So that's the fun, and one of the reasons I like, you know, throwing this question up because of the overall point it makes about human knowledge. But we do have to get back to what do I want to do here? Here we go. So where are we? Anybody have questions so far on how I'm doing things? Having a good time? Remember, I want you to enjoy this course more than any other course you've ever had or ever will have. It's a stiff order, right? All right. So looking at what we're doing for today and tomorrow and Monday, and I'm sorry how my notes go with a Wednesday Monday thing. That's because of the holiday. I had them based on a two class day thing. But we're looking at Plato both today and on September 11th. How many of us are all coming on September 11th? We're not in tall buildings, so I can't imagine airplanes crashing into them. My dad's company was in one of the buildings in New York. They lost 250 people. My dad was retired and didn't work there, but he knew a lot of the people that did, so that was interesting. Okay, so Plato, we'll be looking at Plato. Remember, we're looking at Socrates already. Well, of course you have to do Socrates. But Plato is the one that we have quotes from in almost every area of philosophy and science and psychology and everything, right? Because Plato basically started all of these basic questions for us. And that's why we hear the quote, all of philosophy is a response to Plato, or a reaction to Plato. And then, by the way, I like the other part of that quote, and all of contemporary philosophy is a reaction to Hegel, but that comes later. We'll do that later, right? So Plato is significant for us. And what we saw, of course, is the blend between Plato and Socrates, who is really the one writing all this stuff? Well, Plato is apparently the one writing all this stuff. And Socrates is his main character, and we know that a lot of it is historical, as far as we can tell. I mean, when you figure, did Socrates really exist? Some people ask that, in the same way that some people will ask, did Jesus really exist? Well, really, with all the citations and everything on both individuals, it's kind of absolute that both of those individuals lived. What actually happened, and so on. So when we look at Plato's, and by the way, that's why a lot of people compare Socrates